Good day, students. You are welcome back to this channel. In today's class, we want to understand linear and non-linear differential equations. So, a linear differential equation. A differential equation is said to be a linear differential equation if the following conditions are satisfied. The first one, the highest degree of the independent variable, dependent variable, and the derivative do not exceed 1. This is what I mean by that. We cannot have x raised to power 3, which is independent. You cannot have y raised to power 5, dependent. And you cannot have your derivative, any order. You can, let's say order 2, you cannot have like 5 or 4 or anyone. For it to be linear, it can only have x, y, dy, dx, d squared y, dx squared, and so on. But the degree cannot be more than 1 for it to be linear. Now, there are no occurrences of the product of the dependent variable with its derivative. That is, you cannot have y multiplied by d squared y dx squared. So it cannot happen. So you cannot have the product of the dependent variable with its derivative. But you can have the product of independence with the dependence. That's what can happen. You can have the product of independence with the derivative. So that one can happen. But the dependence multiplied by its derivative cannot happen in linear differential equation. The third one, non-linear functions such as sine, cosine, tangent, exponentials involving dependent variable or derivative do not occur. That is, let's say we want to write the differential equation, we now have d squared y dx squared plus sine y equals x squared. Is this one a linear? It is not a linear differential equation because I said in the last condition that there should not be involvement of sign of dependence, or we now say that sign of the derivative or exponential. So this one cannot happen. This one cannot happen. So this one is not a linear differential equation. Why? Because here there is sign of y. And if you look at this one also, we said from the first condition that all the variables there, their degree must not exceed 1. So this one has exceeded 1, which is 2. Then the other one also is not a linear differential equation because there is what? The sign of the derivative. Another one we can still have, let's say we have the cube y dx whole plus exponential y equals x y. So is this one linear? It is not a linear differential equation. Why? Because we have the exponential of what? Of y. Although we can have the exponential of the independent x, but you cannot have the exponential of y, you cannot have the exponential of dy dx, you cannot have a tangent of, y plus dy dx equals 0. All these ones, they are not linear differential equations. So the general form of linear differential equations for order 1. Here is how differential equation of order 1 should look like. This is the the order of the highest derivative of this one is 1. So this is order 1. Then after here, you can have any function of x multiplied by our y is equal to function of x. So this is the general form of linear differential equation of order 1. So if you now want to write for order n order, you can now say we have a naught, the n, the y, the x raised to power n, then plus a 1, the n minus 1 y over the x n minus 1 plus a2, the n minus 2 y, then the x n minus 2 plus. So we get to a n minus 1, then the y, the x, then plus a n y is equal to what? Maybe f of x. So where a naught, a1, a2, and so on, they are constant, they are either constants or functions of x. Because we said that they cannot, a dependent variable cannot multiply its derivative if you want it to be linear. But this one can be function of x. The function of x can be multiplied by the derivative or constants. So we are going to solve examples under that. Till I see you again. Bye bye.